Let's just do a little bit of quick review. I've given you last week a copy of the problem we want to solve. It's also part of the lecture, basically. Can you see? So I've given you a copy of this. This is in your lecture notes. Anyhow, so I just cut and paste it on a piece of paper. So you're in the class and you can do a bit of exercises. Hopefully all of you have got a copy. Is there anybody here that doesn't have a copy of this? Yeah? Okay. I'll just send it around. Can you pass it around? Thanks. So this is actually part of your lecture notes, but I just printed it so you see, you get the page. This is a Canberra insurance company. That's in this lecture. Okay. All right, let's move on with this. This is lecture review. What we did last week and this week. Entity relationship diagram is a data modeling tool that basically allows you to model the data for a given scenario to build a database from your data model. The ER diagram and its related documents will be used to create your database. And what I will do today is here also create the database as we go. Just a basic database from the problem we will be solving. So the notation on entity relationship diagram, entities are put in the boxes. Relationships are the lines that joining these entities or the boxes. Type of relationship, one-to-one, one-to-many, many-to-one, many-to-many. And if you have many-to-many relationship, you convert that relationship into a new entity. So you should not have many-to-many relationships on your ER diagram. If you have, convert that relationship to a new entity, as we said. So what we did was, what we'll do is, we'll read the scenario, the problem specification given, and sometimes the problem specifications are ambiguous. So you need to go back to the owner of the problem, the people who defined this scenario, and ask them for clarification. ER diagrams are really interesting because you can show them a diagram and explain to the users or the owner of the problem saying, this is what I think your database should do or should look like. And these are the information I'm going to store. These are the relationship between these entities or tables or whatever. So what you do is, when you read the scenario, identify the entities and attributes, okay, and then figure out which attribute belongs to which entity or which attributes, which data items you need to store. Identify, once you know the entities and their attributes, create a primary key for each attribute. One of those, one or more attributes of the entity can become your primary key, or you can create your own primary key. And then you identify the relationships from the scenario and set the foreign key. So you just follow the scenario, the problems, the specifications, and you design your ER diagram based on that. Once you know all the entities, attributes, and you find out all the primary keys and set all the foreign keys, you can just draw the ER diagram. Oops. The problem we're trying to solve is this. The InsureCanberra. InsureCanberra is an online broker company that provides different type of insurance, such as car, boat insurance, house and contents insurance. The company has 35 employees, 5 customer support branches. Right? So here is a bit of it, just the first paragraph of the scenario. Okay? So what it is about, we've got a company that provides car, boat, house, and contents insurance. So what is the entities here are the car insurance, boat insurance, house insurance, contents insurance. So you just may have picked up insurance, but remember, there are different kinds of insurance. The other thing that you know is that the company has got 35 employees, 5 branches. So you need to store the details of the employees and the branches for this company too. And here is the scenario in the second paragraph. To obtain insurance, it could be a boat, house, car, contents insurance, or just a quotation for an insurance, the customer goes to the website of this company, chooses the type of insurance they want, fills in the form, a quotation is then sent to the customer on their screen. If the customer accepts the quotation, then the customer makes an online payment for the insurance using a credit card. So InsureCanberra also provides an appointment reservation facility where customers can make an appointment to come and see a customer, to see a staff. If they need to speak to someone, they just make a appointment reservations online, and then they come to the branch on the date and time that they requested, and then meet someone and discuss their insurance needs. For reservation, a customer enters his or her name, the first and last name, contact details, telephone number, postal address, preferred date and time of the appointment. An appointment is then made for the customer, and an insurance staff of this company will then visit the customer at the customer home at the appointment time and date that they have set, and the customer can then purchase the required insurance during the appointment with the staff. The company has a database, and this database is required to provide the computer-generated daily report. What I did was, to some degree, purposely make this bit short, with a few ambiguities in it, because that's what really happens in real life when you go at work and you want to design a database. All specifications or everything is not there. This used to be an assignment, I think assignment 1 or assignment 2, so we just shrink it from 3-4 pages into 1, and what we ask you here is to create a database for this. So this report, the report that is generated daily, shows all details of all customers that have taken a new insurance policy within the last 7 days. It includes the description and insurance fees for each customer. This report also shows the details of all past appointments made by all customers that have taken an insurance policy within the last 7 days, ordered by customer name. The report is ordered. So what you will see here is there's more details. It's saying you need to know the details of all the customers, all the insurance policies that they've taken, all the appointments that they've made. So what it is saying is, to be able for you to generate such a report, you have to store the customer details. You have to store all the insurance details. You have to store all the appointment details. You have to store all the payment details for each insurance. So this is no doubt that you need all that information in the database for you to be able to generate this report. Right. Let's go back now and go through this scenario again. So now you know what the scenario is. So when you have a problem, a scenario given to you like this, you read, try to understand it, you write a note for yourself, anything that's ambiguous, and of course you come and see me, because I am the owner of this problem during this semester. So if you've got, if you read your assignment 1, there's something ambiguous, you can email me, you can come and see me, so I can explain to you what's happening. But today we have got this scenario. And we need to identify first all the entities in this scenario, then the attributes, and then see which attributes belong to which entity, then set the primary key, set the foreign keys, etc. Okay. How do you do this? You've got the scenario in front of you. I can also put it here. That's probably easier. Here we go. Let's go through it. And because this is your first problem you're trying to solve and build a database for, let's just be a bit patient, go through it. As I said, this is a very condensed problem from a very big problem. So lots of things are missing. And anything that's missing and ambiguous, you can ask me and I will answer. So here, let's go through the first paragraph and let's see if there is any entities or data items in this paragraph. So now we'll, I don't have my highlighter here, so I just put a just underline it. What I think is could be an entity. So here, can you see? Insurance is an entity that I need to store details about for this company. The problem is this, that we have different type of insurances that this company offers. Car insurance, boat insurance, house insurance. And each one of these insurances will have different attributes. For example, for your car insurance, you probably have got registration number of the car that you're insuring, yeah, a make and model. For your boat insurance, you might have the size of the engine, size of the boat. So you don't have this kind of attribute for a car. For a house, you might just store the address of the house, you will store the address of the house, number of bedrooms, type of the building. Does this make sense? So if I just choose one entity called insurance, I will have a little bit of problem because different insurances have got different attributes. So let's separate them. Let's say vehicle insurance, and here we list all the attributes. Boat insurance, and we list all the attributes. House insurance, and we list all the attributes related to the house insurance. And I think if you continue on the same paragraph, you'll see that the company has got some employees or the staff. Doesn't matter what you call it, the staff or employees. And it has got also some branches. You see that? This is a very ambiguous scenario. It's been cut very short. Actually, it's good because if I go to the details and I want to show you a scenario that's 6 pages long, you won't be able to make it through this lecture. And also, everything seems to be very simple and hunky-dory, which is not in real life. So in real life, there's lots of ambiguity. So here, I don't know what they store about their employees. I don't know what they store about their branches. I don't know what they store about their insurances, different type of insurances. So I've got to go back and ask this question. Right? Moving on to the next paragraph, you read it before. To obtain an insurance, a quotation needs to be done. So what happens is the customer goes online, fill in their details and the required insurance, and then a quotation is generated. So what we know is, we write the details of all the attributes here. So let's just, there could be many attributes. right? And then let's just continue with the other entities. Is quotation. Is this right? Quotation is one entity. Customer is another entity because we want to know who asked for a quotation, right? And then a quotation is then generated. How it is done, we don't really care at the moment. We don't think about processes. We just look at the data here. Right? Later on, we do the processes. Then what happens is that a quotation is generated. If the customer accepts the quotation, then the customer makes a payment. So we need to store the details of payment that's made. And payments are done using a valid credit card, so validations of the credit card details is done by another program. We don't worry about it right now. We just think of what data. So we, of course, store the credit card details. So in the payment, we store the credit card details, we store the customer details, etc. So the next thing is the next paragraph talks about appointments, where a customer can make an appointment. So one of the things we need to store is appointment details. And of course, appointment details will consist of the time of the appointment, date of the appointment, the customer that we need to visit. Okay, and then of course on the day of appointment somebody goes there and may sell an insurance. If they sell an insurance, the details goes to the payment. The next thing is the reports that are generated. So the reports are generated from the data, from your database, so you don't have to worry about it. Again, this is another process that you do later on. If you have the data, you can generate the report. If you don't have the data, you cannot generate the report. So if you go back to your lecture notes that you have, I'll show you the solution and then we go to the details. Here are the entities I identified. Let me just make it simple for you for time being. I don't know why I made it complicated sometimes. Sometimes I do. Okay, let's just have a look at this. Really doesn't matter. That was correct, but here is the name of the entities: insurance, employee, branch, quotation, appointment, payment, and customer. Here I just created one insurance, and you'll see later on you will have problems because the attributes of that insurance, what would be the attributes? What would be the attributes of this entity? So these are the name of your entities. Quotation is another entity, appointment is another entity, payment is another entity. With some of them I know some information. For example, with the quotation, I know the quotation is for a customer. Okay. So what I can do is, before I move on to this, I can do at least one thing here. I know each entity should have a primary key. Yeah? So I don't know the attributes, all of the attributes. Well, for the first problem we are solving, let's give every entity a primary key ourselves, rather than searching through the attributes of that entity and finding the primary key. What I mean is, let's say for vehicle insurance, I say the insurance number, right, and everything else. For the boat insurance, I said the insurance number, or boat insurance number. For the house, I say house or H insurance number. Sorry, I hope you can read my writing. For a staff, I'll just give it a staff number. And any other attribute. For branch, branch number. And any other attribute. For quotation, quotation number. For customer number. All of these are in the lecture notes anyhow. For payment number. For appointment number, whatever you want to call it. So if you make it readable, something interesting, and alright, this is what I can do. And how do I distinguish, because I write the name of entity here, and the attributes of that entity within a parenthesis in front of that entity. So if something is a primary key, we just underline it. Anything underlined means is a primary key. Alright, from now on you know, very simple. So if I give you this document, you know the entity names are there before the parentheses, the attributes are within the parentheses of in front of that entity. Anything underlined is the primary key. Let's go back. From this scenario, you also know a few bits and pieces. For quotation, a customer makes a inquiry about an insurance. So if I know the customer number and insurance number, I can find the customer information and insurance information. I don't need to store all the information about customer and the insurance. For the appointment, a customer makes an appointment with a staff or employee, and for some information about some insurance. So all I need is to do is store the customer number, employee number, and insurance number. And then if I want to know who the customer is, I go to the customer table and find out that customer. If I want to know who the employee was that went to that appointment, I just go to the employee table or staff table. For payment, a customer makes a payment for an insurance. And of course I have to add bits and pieces here. It's just not all attributes there. Let's have a look at here. It's very easy for me to tell you. Here is the solution that we prepared for you earlier. It's a good idea to have a look at the solution. Mainly, I've got another scenario that we will go through it today, and you'll be doing it also, the same scenario in the tutorial. Not a big deal. It just gives you a bit more information when you go to the tutorial. You'll happily listen to your tutor and get things done much quicker. Here it is, what we identified: insurance, employees, or a staff. I call it the staff, in this case employees, branch, quotation, appointment, payment. And then for the insurance, we said insurance ID, type, and price. Insurance type and price. So what we decided here says type is car or boat or a house. But remember, this is not going to be a great database because it doesn't have any details about each insurance. Here it is. For each insurance, if it's a car, you've got a certain price of $1,000 or $500. So you don't store different type of cars, etc. So this is very limited database. The best way would be to separate the insurances for car, boat, house, etc. Employee ID, last name, first name, and the address, and the branch in which they work. So you see, the employees work in different branches. So branch ID is here. Branch ID, address of the branch, the telephone number and the fax number. One telephone number, one fax number. Quotation ID. For which customer is this quotation? Because if I know the customer ID, from the customer ID I can go to the table customer. That doesn't appear here, it's probably on the next page. And then I will know which insurance they have taken. The insurance ID, I can find out the insurance, date and time of the quotation, the price that was given. Appointment ID, customer ID, employee ID, insurance ID, date. So that's the appointment ID is the primary key. Which customer made appointment with which staff, for which insurance, what was the time and date. Payment ID, who paid it, the customer ID, for which type of product, insurance ID, who processed it, the employee ID, date and time of the payment, amount that the person paid, credit card number, name, expiry date. I don't expect you to be able to do this, but I just want you to see a scenario and a solution. Yes? Sorry? That's a very good question. That's a very good question. When the payment goes through, and this is true, because we said the person makes a payment online, so there is no employee involved, right? There's no employee involved. So you're right. We can remove the employee ID here. That's right. If it is done, because let's say your system connects with the bank system and you just everything is done through the bank system, so you don't need it. I'll go through the details sometimes in the next couple of problems we will solve, and you'll see a staff number can be beneficial if it is processed through a staff, and we'll see later. What's missing in this lecture note is the customer as an entity, with the customer number, name, etc. So I don't know where it is, because I was hoping it is showing here, but it's not. So let's just put that here. Customer is missing. Very interesting. So what we have to do is we just add customer there. With the customer ID underlined as a primary key, and then basically the customer, if the customer doesn't belong to any branch, so we don't need the branch ID. There you go. So if we go back to the solution, you've got this as a solution. There's lots of bits and pieces and they're missing in this scenario. So there was lots of guesswork of what we are going to store in the employee as an entity. Is it the first name, last name, branch number, the address, what do we do? So it's not there. So I don't expect you to be able to guess the attributes. So in the next scenario that we will work, you'll see more details. But from that, you can move on and just draw the ER diagram. So you can see the table branch and the employee. You see the branch ID here appears in the table employee, and branch ID is the primary key of the branch. So that's why you see the relationship here between branch and employee. Yes?
This is the date and time, because it's in multiple entities. Should we label them like appointment, date, time?
Yeah, you can.
Date, time.
Yeah, you can do that. It's the name of the attribute. If you think that's more, you want to put more information, say appointment date and time, payment date and time, then it just makes sense. Because here date and time, we just think it's a quotation date and time. You can put it as a quotation date and time. Doesn't matter the name of the attribute, but if you make it more understandable, it's easier to also read. Yeah. So the rest of the relationship that you see here between different entities is because of what we did here. Insurance doesn't have any relationship with anything else. Employee doesn't have any relationship other than having a relationship with branch. Have a look at the table customer. In the table customer, what you see is customer ID, the primary key, and the rest of them are the attributes. There is no foreign key. There is no attribute in the table, in the entity customer, that's a primary key of another entity. But if you go to quotation, what you will notice is that in the quotation, you have a customer ID. Customer ID in the table quotation is an attribute, but it is a primary key of the table customer. So what it tells you is like there will be a relationship between the customer and the quotation entity. If you look at the next one, next attribute, insurance ID. Insurance ID is just an attribute here in this table, but it is a primary key in the table insurance. You see that? It's a primary key here, and it appears here too. So in here, insurance ID is a foreign key. It's called a foreign key because that's a special attribute here that connects the quotation to the insurance. So from the insurance ID, you can find out what type of insurance and what was the price of the insurance by looking at that insurance ID in the table insurance. If you look at the table appointment, what you will see again is the customer ID is one of its attributes. Customer ID here is a foreign key. Why? Because it's the primary key of the table customer. So I can get the customer ID from the table appointment and search using that customer ID in the table customer and find full details of the customer, their name, their address. I don't need to store it here again. I'll just put the customer ID. Employee ID again is a foreign key. Insurance ID is a foreign key here. In a payment, customer ID is a foreign key. Insurance ID is a foreign key, and that's it. So when we go back here and have a look, the reason you have got relationship between these entities is because of the foreign keys. So you have the branch ID in the employee, that's why you have this relationship. In the customer, in the quotation, you have the customer ID, that's why you have this relationship between the customer and quotation. You also had a relationship between the quotation and the insurance because there was an insurance ID in the table quotation.